So we're going to be starting to solve equations. Up until this point, we've only been simplifying. That means distributed property or combining like terms. So right here, when we combine like terms, we combine the x's with the x's, and we end up with a negative 3x right there, and we simply bring down the 3, and that's all you could do with that algebraic expression. We're not solving right here, we're just simplifying. We are finally going to be looking at equations. What are equations? They're really variable expressions that do have an equal sign. Okay, so we have a variable expression 2x plus 3, there's an equal sign, and there's a 5. Now, the first thing to understand is that an equation is like a balanced scale, right? Whatever you do to one side, you must do to the other. So what do I mean by that? As we take a look right here, there is nothing on the left side, nothing on the right side. But let's say I put something on the right side. What's going to happen to that scale? It's gonna lean over this way, right? Okay. Yeah, it's me. The only way I could put this right here is if I put another same exact one over here. Okay, because an equation is like a perfectly balanced scale. There's equality. That equal sign is right here in between the two, separating the left side from the right side. And this is a reminder to you so you can understand the most fundamental concept of an equation, that whatever you do to one side, you must do to the other. So you could add another one of these right here, as long as you add another one of those over there in order to maintain the balance, right? Or you could take 2 away, as long as you take 2 away, maintain balance, right? So the idea is whatever you do to one side, you must do to the other. You get it? And it's not just, it's with numbers also. Give me a number, any number. 2. 2 equals 2, right? I can do whatever I want to the left side as long as I do it to the right side. So for example, if let's say I want to multiply this whole side by 5, I could do that. But if I do multiply by 5, I'll have 10. That's no longer equal unless I do it to the other side as well, multiply by 5. So I can do anything I want as long as what I do to one side, I do to the other to maintain the balance, right? I could subtract 1 if I wanted to. As long as I do it to both sides, I'll have 9 equals 9. I could divide by 3 if I wanted to. As long as I do it to both sides, the equality remains. So whatever you do to one side, you must do to the other. Let's go down here. It says whatever you do to one side, you must do to the other. I've already demonstrated that visually with my face and also with numbers, right? The goal of solving any equation is to get x by itself on one side. So you want the answer to be x equals a number. X equals 5, x equals negative 2, x equals 0. You want x by itself on one side of the equal sign, okay? Now, if that's the goal, to get x by itself on one side of the equal sign, how do you do that? If you want to get rid of something, you must do the opposite, the inverse operation. If there's a fire, you turn it off with water, right? With the opposite, right? So if there's a plus 3, you're going to get rid of that plus 3 with a minus 3. If there's a times 2, you're going to get rid of that times 2 with the divided by 2, right? So let's go over this first one right here. Here's the equal sign. You have your left side equaling your right side. You want the x to be by itself on the left side. You don't want this plus 2. So to get rid of that plus 2, you're going to do the opposite of plus 2, which is what? Subtract 2, minus 2, that's right. And 2 take away 2 is 0. Now, you could put 0. I'm just going to cross it out because 2 take away 2 is 0. Now, of course, what I've done right there is I've lightened the left side, so now it's off balance. I subtracted 2 on the left. So what do I need to do? I need to subtract 2 on the right, subtract 2 on the negative 8. So whatever you do to one side, you must do to the other and maintain the balance. So we have this x, we have it left over. Let me write it right here. The equal sign just comes straight down right there. And negative 8 take away 2, that's negative 10. And we're done. We have x by itself. It says x equals negative 10. Now if you wanted to double check your answer, you could take the value of x, which is negative 10, and you could plug it back into the original. And let's think, negative 10 right here, if you owe somebody $10 plus 2, negative 10 plus 2, what do you get? You get negative 8. You really do get negative 8. So that's what we call double checking, right? When you plug in your answer back into the original equation and see if it gives you a true statement. Okay. Let's try number 2. Now, what does it say here really? Does it say x plus negative 2? Does it say negative 2 minus x? What does it say? Negative 2 times x. So let's all put a multiplication symbol right there. Now that's what's happening. You have a negative 2 times x. If you want to undo that, right, what's the opposite of multiplying by negative 2? Dividing by negative 2. Dividing by that same exact value, negative 2. And yes, if the number's negative, you better divide by a negative. That way the negative divided by a negative becomes a positive. You'll just have a nice, beautiful positive x left over. And of course, to maintain the balance, what you do to one side, you must do to the other side. And the equal sign is going to come down. And the negative 8 divided by negative 2, that is a positive 4. So I want us to stay organized this way, guys. The equal sign is always going to just be coming straight down. You're trying to get x by itself on one side, and to get rid of something, you do the opposite, and you show your work. I know a lot of us could just look at this original equation and say, negative 2 times what number gives me negative 8? Negative 2 times what number gives me negative 8? Times 4, right? Negative 2 times 4, so you already know the answer is 4, but I still want to see the work, okay? Same thing with the quiz that we have on Friday. If you don't show your work, you don't get credit. Let's move on to number 3 here. What does this say right here? X divided by 3 equals negative 6. So if I don't want this divided by 3, I'm going to do the opposite of dividing by 3, which is multiplying by 3. So when you multiply by 3, you're not even going to really multiply. You just 3 over 3 cancels out. But the only way that canceled out was by multiplying by 3. And of course, what you do to one side, right now you just multiplied the left side by 3. It's all off balance. You need to multiply the right side by 3 as well to maintain that equality, times 3 right there. So what do we have? On the left side, we have x. The equal sign comes down. And of course, negative 6 times positive 3, that's negative 18. That's your answer right there, guys. X equals negative 18. Number 4, this one's so easy that some people get confused. Now, what's my goal? What do I want by itself? X. Here's x. It's almost by itself. It's just a negative x, and I don't want a negative x. I want it to be a positive x. So how do I change that negative to a positive? You could just get your pencil and do this. Boom. Now, what did I just do there? I just changed the sign, right? But of course, what I do to one side, I have to do to the other side. So if I just magically change the sign on the left side, I need to magically change that positive 2/3 to a negative 2/3. So the answer is x equals negative 2/3. Now that's not the correct mathematical explanation, but that's the easiest way I could explain it. The actual explanation would be this. Let me go back and erase this right here. There's really a negative 1 right in front of the x, and that's saying negative 1 times x. So to get rid of the multiplication of negative 1, you would divide by negative 1. That way the negative 1s will cancel. And what you do to one side, you do to the other. You're going to divide by negative 1. In dividing anything by negative 1, it simply changes the sign. So you do get that same answer, x equals negative 2/3. I just prefer to just, I have a negative x here. I'm going to change it to a positive. I had a positive here. I'm going to change it to a negative. So it's up to you if you want to work it out as a negative 1 in the front and then divide by negative 1, or if you just want to change the signs. So we've done the first 4 questions. How about you guys do the next 4 right now? I want to hit pause, and then we're going to just show the answers to save time. Okay, so instead of just providing the answers, I want to explain. Number 1, I did the work already right here. Again, you want to get x by itself on one side. So where's the x at? Is it on the left side of the equal sign or the right side of the equal sign? It's obviously on the left side. It's not by itself. It has x minus 3. You got to get rid of that minus 3. So to get rid of something, you do the opposite. The opposite of minus 3 is plus 3, right? If you go minus 3 plus 3, that's 0. So I'm just going to put a line through it. What I do to one side, I must do to the other to maintain the balance. Because if I just add 3 on this side, it'll be off balance. I need to add 3 to the other side to get the balance. Okay? So when I do add 3 to the 2, 2 plus 3, I have 2, I have 3. I'm going to have 5 altogether. Equal sign comes down. X is all by itself. Now that comes down. It says x equals 5. You're done. Kevin, number 2. What does that say right there? It says 3 times x. If you want, put the dot there so you can clearly see that it says multiplication. You want to get rid of the multiplication. So Allison, what are you going to do to get rid of that multiplication? You're going to what? Multiplication is division. Sorry, I didn't have my mic on right there. So that's going to be division of 3. It's going to cancel division of 3, which you do to one side, do to the other to maintain balance. X equals 3. Now, of course, if you wanted to double check it, you'd simply take your answer 3, plug it in. 3 times 3 really is 9. And you have technically double checked it right there. Let's move on to number 3 right here. How do I get rid of this divided by 4? You multiply it by 4. So you put a times 4 right there. Whoops, my bad. Times 4 right there. So you don't really multiply because when you have a 4 on top and a 4 on the bottom, that cancels out. Okay? But what you do to one side, you have to do to the other. If you multiply by 4 over there, you have to multiply by 4 here, which means that x equals what? 32. 32. That's it. Done. Number 4. Again, this is so easy, some people get confused. What's the answer here? Positive x equals positive 5. You don't want a negative x, so you could just say, I'm going to change it. As long as what I do to one side, I do to the other, I'm going to change it. So x equals 5. Of course, the appropriate explanation would be that I really have a negative 1 right here, and it's being multiplied by x, so I would divide it by negative 1, divided by negative 1, and negative 5 divided by negative 1 is positive 5. That's a correct mathematical explanation right there. Anyway, this is what we're doing today, just one-step equations. We're going to be adding to get rid of subtraction. We're going to be multiplying. We're going to be dividing to get rid of multiplication. We're going to be multiplying to get rid of division. So we're going to be doing the opposite, and it's going to be simple one-step equations. Now, at the bottom of our handout here, we have two-step equations, which is going to introduce us to what we're going to be doing tomorrow. So let's take a look at number 1 here. So two-step equations. Now, what do we get rid of first? X is obviously on the left side of the equal sign. Do we get rid of the 2 first or the 3 first? The 3 first, right? Now, the explanation is this. Normally, we would do multiplication before addition or subtraction, but since we're undoing things, we would get rid of the plus first and then get rid of the multiplication. The way I like to think of it, the quicker way to understand what to get rid of first is, what's the most important thing out of this whole equation? X. You want to get X by itself. X is the movie star. That's Mr. Important right there, right? The 2 is really close to the X. That's like the movie star's buddy, right? This 3 is like a bum at the corner. You don't care about this guy, right? So when it comes to who do you want to get rid of first, you're going to get rid of this guy first. So how do you get rid of a plus 3? By doing the opposite, which is minus 3. Of course, to maintain the balance, what you do to one side, you do to the other side. You will end up with this 2x left over. The equal sign comes down. 5 take away 3 is 2. I'm sorry, I didn't bring down the equal sign. And now we have a one-step equation left. The original was 2-step. Now we have 1 step left. This really says 2 times x. To get rid of the multiplication of 2, I do what? Divide by 2. And what you do to one side, you must do to the other to maintain the balance. So you really do have x equaling 1. Let's try number 2. Number 2, I have x on the left side of the equal sign. It's definitely not by itself. Okay, it's not by itself. So what do I get rid of first? 4. The bum at the corner, the 4, right? So we're going to subtract 4 to get rid of it. Remember, x is the movie star. The negative 3 is close to the x. That's like the movie star's buddy. This loner right here we want to get rid of. So what you do to one side, you do to the other. Subtract 4 there, subtract 4 there. And of course, on the left side, it disappears. 4 take away 4 is 0. What do we have left? We have a negative 3x. The equal sign comes down. 16 take away 4 is 12. So now we're faced with the easier equation that says negative 3 times x equals 12. Now we already know, or we can figure out, that negative 3 times 4 equals 12. But I don't want you to just jump to the answer. I want you to actually show your work. To undo the multiplication of negative 3, you're going to have to divide by negative 3. That'll cancel out. What you do to one side, you do to the other side. X equals negative 4. Let's jump to number 3. Once again, if you wanted to check this answer, take that negative 4, plug it right in there, and say negative 3 times negative 4, that's positive 12. And 12 plus 4 really is 16. That's how you're absolutely positive that the correct answer is negative 4. All right, let's try number 3 here. What do I get rid of first?
Negative 4.
The negative 4 by doing what? Adding 4. What I do to one side? I do to the other. Notice I'm staying organized, guys. This equal sign comes down. The -4 and the +4, that becomes 0. I could just cancel it out. The -2x, I bring that down. And the -12 plus 4 right here, what do I get? -8. If I owe $12 and I only have $4, I'm still going to owe $8. So this was my original bigger equation. Now this is my nicer equation that I only have one step left. So it really says -2 times x. How do I get rid of that multiplication? Divide it by that same exact value, -2. Now if you divide it by +2, that would get rid of the 2's, but the negative will still be there, right? So it's better to divide it by that same exact -2 value. That way it completely cancels out, and it really just becomes a positive x. The equal sign comes down again, and -8 divided by -2 is +4. There's my answer there. Last one. What do I get rid of first? The +4 by doing a -4. Cancels. What I do to one side, I do to the other. Now, maybe I shouldn't use the word cancel, because 4 take away 4, that's really 0, right? But it would be pointless for me to write -2x plus 0, because that's still going to be -2x. That's why I just put a line right through it. Okay. Now over here on the other side, of course I'm going to bring down my equal sign. On the other side, 4 take away 4, that really is 0. And 0 is a number, so we need to write down that number right there. 0 is a nice whole number. Now we still have an equation that reads -2 times x equals 0. So how do I get rid of the multiplication of -2? You divide by -2. That cancels out. What I do to one side, I must do to the other. Now 0 divided by anything is 0. 0 divided by -2 is 0. 0 divided by 1,000 is 0. 0 divided by any number is 0. X equals 0. And that's it for the lesson today, but we are going to jump into a homework assignment, WSP 2.1. Those are simple one-step equations, not two-step equations.